Okay, so now we're going to compute the range of a set of data. So we stopped off, we were calculating standard deviation. I'll give you a couple of other examples with that, and we'll actually look at that here in just a little bit when we talk about the empirical rule. But range is very easy to find. I am going to show you how to do that on the calculator. With 10 data points, you should be able to find the highest, the lowest, and then subtract the two. So you should remember that the range is the max minus the min, and it tells us how far apart the data points are. Now, it's not a very good measure of dispersion. It's also, or measure of spread. It's also it's not a resistance statistic. So remember, if we're calculating this value, this looks like that's the highest, and then 62 looks like it's the lowest. Of course, we're going to use technology to verify this, but the range is the max minus the min. And then you are looking at that. Again, it is not resistant. So if I change that 94 to 1004, it's going to change the range drastically. So it is affected by extreme values. Now, when we're looking at this value here, I went ahead and entered the data into the list. Remember, and I'm going to show you how to clear out the list as well. A lot of you are going to be tempted to hit delete when you're in something like that, okay? You definitely don't want to hit delete. If you hit delete, if this will go up there, what's going to happen is it's going to delete out the whole list. So, oh my gosh, my list 2 is gone. We don't want that to happen. So if you do that, you can go ahead and insert the list. I will have to show you all this. But if you see what I did, I hit second insert. So let's go ahead and delete that again. Oh, it won't let me. I have to put something in there. But so I'm going to hit second 2. I'm going to insert the list 2. It's still there. You want to hit clear and enter instead of delete whenever you're clearing out a list. So remember, you're clearing the list, not deleting the list. So you highlight the values and then clearing the list, not deleting the list. And we'll write that down. Now, with this list 1, we want to calculate one variable stats because we want to find the range. The calculator, I'm sure it will find the range. That's not something I usually do because it's just extra stuff when it's super easy to find the max minus the min. So our max was 94, our minimum was 62, and then we subtract the two values. And 94 minus 62 is 32. So the range here is 32 points. So 3 letter grades is the range in the scores, and it ranges from an A to a D. So nobody failed the test in this case. And it's 10 students enrolled in introductory statistics. This is a sample. That doesn't mean that no one failed the test. It just means in the sample that it didn't. And again, the range is not resistant. Okay? And remember, clear the list, not delete. Now it says, determine the standard deviation from raw data. I could show you how to find this by hand. I'm not going to anymore for this, for our purposes. So we're not going to find it by hand. We're only going to do this with technology. Now, variance is something that we're going to take a look at. So if we go back to the last example that we were looking at, and we look at the data there, our standard deviation, this is a sample, is 10.3. We usually round to one place. The variance is defined as, so the standard deviation is 10.3. The variance is defined as S squared. So it is 10.3 squared, or 10.3 squared, which is 106.09. And the variance, you can see here, is the square of the standard deviation. The population variance is sigma squared. The sample variance is S squared. So do highlight that. Do make a note of that. You do want to be able to come back to that and take a look at it. Now, this is your empirical rule. This is something I would write down on a note card. This is something you're going to want to have. The empirical rule discusses what happens with symmetric data. What can we expect? And we're going to be using this probability. We use it a lot, actually, when we're testing hypotheses and different things like that. So this empirical rule is something that you're going to want to have. And it says use the data from the table to answer the questions. And it says, determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. So when we look at the empirical rule, the percentage of individuals within 3 standard deviations is 99.7% of all individuals will fall within 3 standard deviations of the mean. And then I might have accidentally inserted some other stuff there. It says determine the percentage of IQ score. So we're going to go over this part first before we look at this next example. It says in a normal distribution, what percent of the values lie below the mean? The mean is the peak. So this is your mean. It is based off of the population mean. So all of this is all population. Later, we're going to look at what happens if we use a sample that's called a t-distribution. This is called a normal distribution. Now, that is in the middle. So 50% of the values lie below the mean. 50% of the values lie above the mean. How many values lie within 1 standard deviation of the mean? That's kind of what we were looking at up there. 1 standard deviation is going to be 1 standard deviation this way, 1 standard deviation this way. So when we are looking at 1 standard deviation away from the mean, 68% of all values will fall within 1 standard deviation of the mean. So here, this is area, is what we're looking at. And this is I'm going to try my best to highlight this. So this is 68% of all data points. This is symmetric, so that means 34 is here and 34 is here. Next, it says within 2 standard deviations of the mean. So we're increasing our spread here. Within 2 standard deviations, we're increasing all of this to 95% of all data. So when we add this section here and this section here to the pink, we've increased it from 68% to 95%. Now, when we look at the difference here, 95 minus 68 is 37%. That's just kidding. That's 27%. And that, keep in mind that this is symmetric data. So if this orange represents 27 extra percent of data, then this is half of that. That's 13.5%. And that is 13.5%. And that is where the numbers up here come from. So you can see that. And then within 3 standard deviations of the mean, we just discussed that. That is 99.7% of the data. So when we go here, we're looking at 99.7%. So we're adding in 2.7% of additional data. So when we go from here to here, we have 99.7 minus 95. So we're adding in 2.7% of the data, which means this is 4.7% of the data. I promise I can subtract. So this is 2.35 and this is 2.35. Because remember, this is symmetric. You have half of it on one side, half of it on the other. You can see that. Half is on one side of the mean, half is on the other. And then not all of this adds up to be 100%. It adds up to be 99.7%. So the remaining portion of the data, which is going to be on the outside out here, is 0.3%. Half of 0.3 is 0.15. So 0.15% of the data lies out here. 0.15% of the data lies out here. Now, we have a situation where 2,000 freshmen at a state university took a biology test. The scores were normally distributed with a mean of 70 and a standard deviation of 5. Okay, cool. What does that mean, though? So our mean always goes in the middle. That's going to be this point because this is symmetric data. So our mean is 70. So the mean always goes in the middle because it is the center of the data. So remember, we discussed that as the center. And then it says it has a standard deviation of 5. So on the positive side of that, we add 5. So this is 75, this is 80, and this is 85. So 99.7% of our data, the upper bound is 85. And then on the lower end of that part, we have that we're going to subtract 5. So we have 65, we have 60, and then 55. So 99.7% of our test scores of this 2,000 freshmen at State University are going to be between 55 and 85. So it says what percentage of the scores range between 65 and 75. So what I do is I look for that information. So we're going to go with 65 and 75. That is within 1 standard deviation of the mean. So that is 68% of all tests will fall between 65 and 75. Now, eventually we're going to look at, okay, what happens if it's 85%? What does that tell me? What does that mean? And you're going to have to be able to interpret that. Next, it says between 60 and 85. Now, sometimes it can get a little tricky. Sometimes it's not just within 2 standard deviations of the mean. So within 60 and 85. So we're looking from here to here. So 60 to 85, and you're going to go right to left. You have 13.5%, you have 34%, 34%, 13.5%, and 2.35%. So essentially you have 95 plus 2.35 right here, because you have 68, you have the 95 plus 2.35, so you have 97.35% of all test scores will fall within that range. What percentage of scores are less than a 55? So when we're looking for less than 55, this is our boundary, and we're going this direction. So we have that 0.15% of scores are less than a 55. Next, it says what percentage of scores are greater than 80? So we go to 80, that's our bound. And then we want greater than, so that's going to be everything to the right of that. So then I take those percentages. Remember, those percentages are not going to change in the problems. The only thing that's going to change is what's below the line, the scores there. So I have 2.35% plus 0.15%, which gives me 2.5% of all the tests should be above 80. And then it says approximately how many biology students scored between a 60 and a 70. So same thing here. We're looking between 60 and 70. So we're looking in this range right here. The percentages there tell me 13.5% plus 34% are going to fall within that range. When I add those two together, that is 47.5%. So less than half, which would make sense because this point represents half and we're not going all this way. So it's going to be less than 50%. And then we add those values together and that's what that tells us. And then it says approximately how many. Now notice I didn't answer that question. It says approximately how many biology students scored between 60 and 70. It doesn't say what percent. This time it says how many. So I have to take this percentage, which is 47.5%, and I have to multiply it by the 2,000 students. Of course, this is 47.5, so I need to change that value. And then 47.475 times 2,000 will give me that value. And approximately 950 students will score in that range. Okay, I'm going to go ahead and get rid of that. Oh, disco. So 950 students. Actually, I'm just going to write that right there. Approximately how many biology students scored between 55 and 60? So we need to know what percent first. Now I see that right here. So about 2.35% of those individuals scored between 55 and 60. So I'll come over here. I have 0.0235, because that's 2.35%, times the 2,000 students that took the test. And we have about 47 students that scored between 55 and 60. So make sure you're paying attention. Is it asking how many or is it asking what percent? That's going to change how you find your answer. Now, I'm assuming you know how to find how many given a percentage. So, all right. In this example, 1,800 freshmen were admitted to GRU this fall. The scores on the SAT were distributed normally with a mean of 520 and a standard deviation of 90. Label the mean and 3 standard deviations from the mean. So we have that the mean was 520. The standard deviation is 90. So we have 610, we have 700, and we have 790. So I add 90 each time. Then we have subtracting 90. So we have 430. Then we have 340. And we have 250. So 99.7% of all of our scores are going to fall between 250 and 790. Now, the next thing that I'm going to do is I'm going to put the percentages on this number line here. So I copy those from my empirical rule. And once I have these filled in, then I'm going to use that to help me answer the questions. And eventually we'll learn how to find these using technology as well. Because not everything's going to fall on those nice, pretty, perfect standard deviation lines. So this is just showing you how this works. So what percent of students scored between 340 and 700? Notice it says what percent, so I am looking for a percentage, and then it says 340 to 700. So 340 to 700. That is 2 standard deviations to the left and 2 standard deviations to the right. And we know that within 2 standard deviations of the mean, 95% of the data is contained. So if it's a nice even, it's split evenly, then that's going to be part of that empirical rule. Your empirical rule says 1 is 68, 2 is 95, and 3 is 99.7. So since that's 2 standard deviations away, we know that is 95% of the data will fall between those 2 scores. What percent of students scored between, so again, what percent scored between 430 and 700? So we have 430, 700. That is not even, so it's 1 on the left, 2 on the right. So now I am going to take and I'm going to add my values. So we have 34 plus 34. Of course, this is percentage. And then plus 13.5. 68 plus 13.5 is going to be 81.5%. So that is the percentage of students we would expect to score between 430 and 700. What percent of students scored below 430? So we have 430 here. We're looking to the left of this. We're looking at the whole thing. So we have 13.5, 2.35, and 0.15. I know that these two had to be 2.5. 13.5 plus 2.5 is 16%. So 16% of students scored below a 430. This next question says what percent of students scored above 700? So above 700 would be everything this way. So that would be 2.35 and 0.15. When I add those together, that gives me 2.5%. How many students would you expect to score below 520? So we go to 520. That is the halfway mark. That is the mean. We would expect that 50% would be below here. So half of our students are going to score below that 520. So we would expect 50% of that 1,800, or about 900 students, would score below that 520. Okay. This says, given the dot plot below, calculate the mean and standard deviation. Label the mean, standard deviation. On the dot plot, use these values to determine whether the distribution could be normal. That's something we're going to do when we get back together. Okay. And so these are the examples that I want you to use on the empirical rule. If you have any questions, make sure you email me. We are not going to talk about this inequality right here. And now we're going to move on to measures of central tendency. We're not going to do measures of dispersion from group data. We're only going to do measures of central tendency. We're going to find averages, okay? Now, when we're looking at tables of data, we need to know a representative for those. So we're going to look at that here in just right now. So when we look at this specific table, it says, I want to find the average of this set of data. Now, I know how many, I know what the frequency is. That's easy to tell, but I can't enter this into my calculator. So I need to have a representative. I'm going to go halfway in between here. So halfway in between is going to be 8.5. Halfway in between here is 9.5. 10.5. And then so on and so forth. So the class representative, I'm going to plug in the calculator for this, is going to be halfway in between these consecutive upper and lower classes. And now remember, we've talked about this. This is your lower class limit. And this is your upper class limit. Your class width, remember, is the distance between the classes. The distance between each class is 1. So your class width is 1. And then once you have the information, you're just going to input that into your calculator and you are going to find the average. And I'm going to show you how to do that. I'm going to pause the video here and then we're going to resume in just a second. Okay, I'm going to show you how to actually enter this. So we're going to take some time to enter these values. Remember, when you go to enter data, you go to stat, you go to enter. I want my data in list 1 and list 2. So remember, we clear a list. We don't delete a list. So I'm going to clear my data. I'm going to hit enter and it clears that list. Now, my class midpoints are going to go in list 1. So I'm going to go from 8.5 all the way down to 19.5. So that's the first thing that I'm going to enter there. Of course, I'm going to make sure, always going to double check. I don't want my data to be incorrect, as we found whenever we were doing the IQ example, it messed with the data a little bit. And see right there, it was 1.5. So you've always got to be careful, making sure that you're typing in what you think you're typing in there. 13.5, 14.5, 15, and then all the way down to 19. Once you get to 19, then we're going to enter the frequency in list 2. So we're going to tell it how many 8.5s did we have, how many 9.5s did we have, and so on. So I had 2 8.5s, I had 2 9.5s, I had 4 10.5s. Now, based on us using the class midpoint, this is going to be an estimate for our average. It's not going to be the actual average because we don't have a listing of all of the true data points. So we had 1 16.5, we had none, no 17.5, no 18.5, and then we had 1 19.5. Now, once we have this information, we're going to go just like we did before to stat. We're going to calculate one variable stats. We're going to find the mean, we're going to find the standard deviation, median, and all of the things, okay? So I go to one variable stats. This time, we have 2 lists, so that's where this frequency list comes in. My frequency list is in list 2, and so I tell the calculator, hey, this time I have a count instead of just everything in one list, and then I tell it to calculate, and this gives me my average. So the average value was 13.1. The standard deviation, this was a sample. So the standard deviation was 2.182, and we'll write this down. And then the median value is 13.5. Okay, so you can see the minimum value, you can see the quartiles, the 5-number summary, all of those values, okay? So when we look at writing this information down, the average rate of return over this 5 years was the 13.1. This was the sample. So the average rate of return was 13.1%. The standard deviation rate of return was, I think I said it was 2.182 or something like that percent. And again, 3 decimal places because my original data has 2 data points. And then my median was 13.5. And then I'm going to leave it to you all how to find the median. That will be a bonus on your test. You're going to have to find the median without using a calculator. So for your bonus on this test, on this section, you're going to have to find the median without using a calculator. So you're going to have to figure out how to do that. Okay. Now, on this one, approximate the average temperature below from the data. So this one's a little trickier. So here, this is 4 apart. So I can say 61 to 65, that's 4. So the average there is going to be 63. That is in that class. Okay, good. 65 to 68 is 3, so that's 1.5, so that's 66.5, also in the class. 68 to 70 is 69, also in that class. There's only one value in this class, so it is its own representative. 71 to 73 is going to be 2, so it would be 72 here. 73 to 77 is 4, so that's 75, and then 77 to 80 is 78.5. Okay, now these classes are not even at all. So if you don't like the fact that this is further towards one side than the other, you can always take and say 61 to 64 is 3. So you can actually find the middle of the numbers that class contains. But keep in mind that goes all the way up to 64.99. So that's why we're doing it the way we do it there. And then we're going to find the average temperature. And it stopped mirroring for me. When we go to find this value, we are going to type this in. Again, you're going to go to Stat. You're going to go to Edit. This time we have 2 lists, so we're going to go ahead and clear out list 1 and 2. So remember, clear your list, don't delete your list. And then we're going to enter our class representatives in list 1, our frequencies in list 2. So we have 69, we have 70, 72. Now, the key thing with this problem is that 70 to 71 would give me 70.5. I want to make sure that I'm using the values that are represented by that class. And even though technically it is in that class, I'm going to just go ahead and go to 70 because everything is to the nearest degree. So 75, and then we have 78.5. And then we put how many of each temperature we had in the next list. So 63, we had 31. And I'm going through and I'm checking this as I'm entering. 66.5 is 67. We have 198. 69s. We have 195 70s. We have 120 72s. We have 89 75s. And then we have 50 78.5s. We go to Stat. We go to Calculate. One variable stats. Now, this is another thing you have to be careful. If you are not working in a section that has a frequency list, a lot of times people will forget to delete that out. Now, this one does have a frequency list, so I go ahead and hit enter. The average temperature is 70.6. The standard deviation temperature is 3.4. And then the median temperature is 70. And that is how you're going to find those values of group data. Again, email me if you have any questions. You will have an assignment over this. I am here to answer any questions you need. And I will make sure that you understand what that is, because you will have to find the average and the standard deviation of group data. It's really easy as long as you know how to enter the information and interpret the information in the calculator. This is the official formula for a weighted mean. Okay, so you can go back and look at that. This symbol right here represents the sum of a group of data. Okay, so if I say the sum of all x's, and then I give you in a table 7, 4, 12, That just means to take all of these values and add them up. So 7 plus 4 plus 12 is 23. So when you see this capital sigma, it just means add everything in a value. Now, here, so for example, your college GPA. Miss McCoy is taking a calculus course. So that calculus course is 4 hours. She's taking a biology course, which is 4 hours, a PE course, which is 1 hour, and then an advanced algebra course, which is 3 hours. At the end of the semester 1, I made an A in calculus. I made a C in biology. I made a B in PE. And then I made an A in advanced algebra. And now I want to calculate my GPA for the semester on a 4-point scale. So here is how you're going to do that. The easiest thing to do is to make a table. So I have a calculus course that is worth 4 hours. So when you calculate your GPA, you need to know how many hours the course is worth, and you need to know what grade you made. And the grade has to be numeric, so it can't be ABC. It has to be 4, 3, 2, 1. And remember, F receives nothing. So in my calculus course, that was 4 hours. In that class, I made an A, so that is 4 points. In my biology course, I made, which is 4 hours, I made a C. That is 2 points. In the PE class, which is 1 hour, I made a B, which is 3 points. And then in the advanced algebra class, which was 3 hours, I made an A. So that is also 4 points. Now, you can do this in the calculator. It's not very hard to do it by hand. So in all, for this class, I made 16 points. For this class, I had 8 points. For this class, I had 4 points. For this class, I had 4 points. This class, I had 3 points, and then this class, I had 12 points because I multiplied 1 by 4 instead of 1 by 3. Now, this semester, I took 8, 9, 12 hours. So in order to figure out my GPA, it's grade divided by hours. So GPA is grade, or points, so let's say points, divided by hours. So I have to figure out the total number of hours and the total number of points per class. So 16 and 8 is 24, 36, 39. So I got 39 points out of a total of whatever I could have gotten. And then I took 12 hours. So we have 39 divided by 12. And my GPA for that semester was 3.25. So the GPA for that semester was 3.25. Okay? And that is how you're going to calculate a weighted GPA. Computing class average. In Marissa's calculus course, attendance counts for 5% of the grade. Quizzes count for 10% of the grade. Exams count for 60%. And then the final exam counts 25%. Marissa had a 100 average for attendance. So that was pink. A 93 on her quizzes. 86 for her exams. So that's green. And then 85 on the final. What was Marissa's course average? So same thing. In my grade, I had a 100 for attendance. That 100 represents 5% of my grade. I had a 93 total average for the quizzes. That represents 10% of my grade. The exams, which I had an 86 on, count as 60% of my grade. And then I made an 85 on the final, which counts for 25% of my grade. And then I'm going to make sure that all of this does indeed add up to be 100%, because if it doesn't, then I have done something incorrectly. Okay, so 25, 85, 90, 100. So that is 100%. I do have all the categories. And now I am going to calculate the percentage. So 5% of 100 is 5. So I got 5 total points for attendance. 10% of 93 is 9.3. So for the quizzes, I got 9.3 points towards my final grade. 60% of my grade was an 86. So I do 0.6 times 86. And that is 51.6. So I got 51.6 points towards my final grade from the quizzes. And then last but not least, the last 25% was from that 85. So I do 0.25 times 85. And I got 21.25 points. Now, keep in mind, 5% plus 10% plus 60% plus 25%, I think is what it is, equals 1. Okay, that's going to be important. So here we ended up with 21.25 points. And then we have to add those to get our final score. So we have a 5, 3 and 6 is 9, and 2 is 11. 14, 15, 16, 17. And then we have 7, 8. So we made an 87.15 in the class. And then technically we would divide that by the percentage, which is 1. So we ended up with the 87.15. So we made a B for the class. Which would make sense because the bulk of our grade came from those two values, and that is in the 80 range. So that does make sense. All right, that is your last example. You will have homework problems from that. If you have any questions, definitely let me know. And I will talk to you on Thursday.